What's Gucci, everybody? It's AJ here again, and today I want to talk about the relationship between pointers and arrays. Misspelled that there, but trying to type as fast as possible. But anyway, as we have learned about pointers and how pointers contain addresses to variables, and then at those addresses of the variable, they contain the values of those variables. Pointers and arrays have a special relationship. Now, as we learned about pointers, we learned that if I have an int I equal to 80, and if I have a pointer int I ptr is equal to the address of I, that I need to give the pointer the address of I, because that's what pointers store. They store addresses. Pointers take addresses of variables as their values. But there also is a way to have a pointer point to an array. Yes. So, let me show you guys an example here. Let me create an array of, I like to call it array, of size 5 will do, and I'll call it 1, 2, 3, 4, 5. And boom, and let's say I have my pointer. I have to make the pointer the same type as the array types is, because as you see, this is very important in a second. So I'm going to call this array ptr, and I'm going to set it equal to array. I'm not going to use the address symbol or anything like that, and let me just get rid of this for easiness and only looking at this one thing I want you guys to look at. So as you can see, I have an array pointer, and I'm assigning it the value of array. Now, what is the value of array without the brackets? As you can see, I am not assigning the pointer to the 0th position or the first element or anything like that. What I'm doing here is I am actually still giving array pointer an address. And what's happening is that each array, the array variable on its own, is the address of the array. Or what it means is that I am giving it the address of where the array starts. So arrays in memory start at wherever they're located, and what happens is the next elements in the array go along right next to it. So for instance, this 1, 2, 3, 4, and 5 in this array are all stored right next to each other in memory. And what I'm doing here is I'm giving this pointer the beginning of the array. So I am giving it the location of where the address or location of where the array starts, which in this case is the address of where the 1 is located. So if I print out, for instance, just to show you guys, if I print out %d, this array pointer, I should get 1, because the array pointer, I am dereferencing the pointer, and it is at the 0th position of the array. Boom, and I get a 1. Let me put a new line here for what I'm about to show next. And let's say if I wanted to easily look at the 2nd or 3rd or 4th or 5th element of the array. Actually, this is pretty easy. All I need to do is I need to do something that will catch you off guard here. All I need to do is I need to increment the array pointer without the dereferencing symbol. And what this is doing is, let me put this out just to show you. I get 1 and I get the 2nd element 2. What this is doing is pretty incredible, is that since the array pointer has a type integer, it knows how many bits each element is taking up. So what this does is the array pointer doesn't advance just 1 bit in memory. I'm not incrementing the address by 1. I'm actually incrementing the address by the size of its type. So in this case, a integer, at least on my computer, has a size of 4 bits or 32 bytes. Sorry, it has a size of 32 bits and 4 bytes. I cannot mess that up. And basically, since they're strongly typed, when I increment this or decrement this, it knows to go up or down 4 bits. Now note I could also do array plus equals 2 to advance 2 elements to 3, but that, in terms of memory, that's advancing my pointer, the pointer address, by 8 bits. 8 bytes. There are 8 bits in a byte. And so what that is doing is, since it's strongly typed, then it would do that. So as you can see, I incremented it by 2, which is straightforward thinking on your part. I incremented to the second element, but in the computer memory, I'm incrementing it by 8 bits in terms of an int. Now, if I were to change this to a char array and a char pointer, a char only has a size of 2 bytes on my computer. And so incrementing and decrementing it would change the address by 2 in relativeness to only changing it by 1 index on the array. So as you can see here, this is a way to increment to go through the array. I can increment it, decrement it. See, I can increment it, and then I can decrement it again to get back to where I go. And this is an easy way to go through an array with pointers. So the key lessons to this tutorial are to remember that an array name without any indexes or anything is automatically an address to where the array starts at index 0, which in this case is 1. And you can easily, since C is strongly typed like this, you can easily increment and decrement up and down the array if you wanted to. I hope you guys enjoyed this tutorial, and I hope everything makes sense. I will see you guys.